Now that we have three separate networks and three separate broadcast domains, let's see how data flows from a PC on one network to a PC on a different network, focusing on Layer 2 and Layer 3 addressing. We'll also see the major difference between Ethernet switches and routers in action. In this example, PC 1.2 wants to send data to PC 3.2. First, the application layer sends the data down to the transport layer, where Layer 4 header is added. Next, the transport layer sends the data down to the network layer, which adds a Layer 3 header. This Layer 3 header includes the source and destination Layer 3 addresses. Remember that in this section, we're using a simplified format, network.host, rather than a full IP address. Moving on to Layer 2, things get a bit tricky. Before the source PC can add the Layer 2 header, it must determine if the destination PC is on the same network by examining the network portion of the destination Layer 3 address. Let's focus on Network 1 for a moment to see what happens within this network. Throughout this extended example, we'll focus our attention on specific areas of our network. We'll keep a thumbnail drawing on screen with a highlight of the portion we're currently focusing on to help you keep track of where we are in the larger network diagram. In the previous example, when PC 1.2 wanted to send data to PC 1.8, the sending PC's network portion was the same as the destination's PC. Therefore, PC 1.2 simply sent out an address resolution request to determine PC 1.8's MAC address. Remember that an address resolution request is sent to the broadcast MAC address, so all devices in the broadcast domain receive this request, including the router. Since the Layer 3 address in the address resolution request does not match the router's Layer 3 address, or in the case of IP networks, the IP address, the router simply drops the packet. It does not forward broadcast frames out the other ports, hence reducing network traffic. PC 1.8 is the only device that responds to this address request. After receiving the response, PC 1.2 will fill in the source and destination MAC addresses and transmit the frame. In this example, however, by examining the network portion of the Layer 3 address, the sending PC can determine that the destination PC is not on the same network, and that the two PCs cannot communicate directly. In this case, the sending PC sends the data to the nearest router, also known as its default router or default gateway. If the source PC already knows the default gateway's MAC address, it skips the address resolution process and sends the packet to the router for further processing. If it doesn't know the router's MAC address, it sends out an address resolution request to determine it. The router will respond with its MAC address. Then PC 1.2 will be able to address its data to the router, so that the router can figure out how to forward it on to Network 3. A default gateway is different from the default route described earlier. A gateway is a device, such as a router, which serves as a door or an access point to another network. End-user devices, such as PCs, send packets to their configured default gateway when the destination network number is not the same as their network number. A router, on the other hand, does not have a default gateway configured, since it is the door to other networks. Instead, a router uses a default route to direct traffic if it encounters a network that is not in its routing table. You might be asking yourself, how does the PC know the Layer 3 address of its default gateway? This address is either configured by the network administrator or learned dynamically. However, as when sending to any device, the sending PC needs to determine the default gateway's Layer 2 or MAC address using the address resolution process before it can send the packet. Once the PC determines the default gateway's MAC address, the PC adds the Layer 2 header using the router's MAC address for the destination address and its own MAC address for the source address. If you remember our discussion of addressing in Section 1, the Layer 3 address identifies the final destination. The Layer 2 or MAC address identifies the stops made along the way to get to the final destination. Layer 2 addresses change with each stop along the route to the final destination. Now that PC 1.2 is ready to send its data, let's take a look at the Layer 2 and Layer 3 addresses that are included in the frame and the encapsulated packet. See if you can identify each of the data elements on screen by dragging a label from the Possible Labels box to the appropriate empty label on screen. Incorrect matches will bounce back. After Layer 2 encapsulation is complete, PC 1.2 converts the data to ones and zeros and sends it over the wire. The Ethernet switch connecting the source PC to the router receives the frame, examines the Layer 2 destination MAC address, and looks for a match in its MAC address table, which, on a switch, is commonly called a forwarding table. If the switch does not find the Layer 2 address in its table, it will send the frame out all ports except the one it came in on. In this case, the switch finds a matching entry for the Layer 2 address, so it only forwards the frame out the port specified for that address. Notice that this Layer 2 device did not look at the Layer 3 header or change the Layer 2 source and destination MAC addresses. Next, the router receives the frame and examines the destination MAC address to see if it is the intended recipient. If so, the router strips off the Layer 2 frame and examines the destination network portion of the Layer 3 address, which in this case is network number 3. The router looks in its routing table for this destination network number. The router finds network number 3 along with the Layer 3 address of the next router in the path to the destination network. Next, the router adds a new Layer 2 frame, including the source MAC address and the next hop router's MAC address. If the router does not know the MAC addresses for the next hop, it performs the address resolution process to determine the MAC address. In this case, the MAC address for 2.2 is BB. Notice that the source Layer 2 address is now AA, since the data is being sent on a different port. Since a router is a Layer 3 device, when it receives a frame addressed to itself, it can strip off the Layer 2 frame and examine the destination Layer 3 address to make an intelligent routing decision. The router cannot change the destination or source Layer 3 addresses. However, a router changes Layer 2 addresses with each hop. In contrast, a switch can access Layer 2 addresses to forward frames, but it cannot change those addresses and it has no access to Layer 3 addresses. So, back at our example, the Ethernet switch connecting the two routers receives the frame. Our data is halfway to its destination. Let's zoom in on network 2 and see what happens there. The switch examines the Layer 2 destination MAC address and looks for a match in its MAC address table. Once it finds a match, it forwards the frame out the correct port. The next router repeats the strip and lookup process. First, it checks the data's destination MAC address. Then, it strips the Layer 2 frame and examines the destination Layer 3 address. But this time, the destination network is directly connected to the router and the routing process is complete. At this point, the router determines PC3.2's MAC address and adds the Layer 2 header including the appropriate destination MAC address and the source MAC address for the port on which it is sending the data. Then the router transmits the data. The switch connecting the router to the destination PC uses the destination MAC address to forward the frame to the correct PC. When the PC receives the frame, it first examines the destination MAC address. If it is the PC's MAC address, the PC strips off the Layer 2 frame and examines the destination Layer 3 address. Again, if it matches, it strips the Layer 3 frame and examines the Layer 4 header. This process is repeated, layer by layer, until the application on the PC receives the data. Our data's journey from PC 1.2 to 3.2 is complete. In the learning activities at the end of this section, you'll have a chance to test your knowledge of Layer 2 and Layer 3 addressing and how data is routed from one device to another across multiple networks. In our previous example, the routers interconnected Ethernet LANs, which use the same Layer 2 frame format. What if there is a WAN between the two routers, or a different type of LAN? Different Layer 2 technologies, such as Ethernet, FDDI, ATM, or frame relay, have unique Layer 2 formats. Since a router strips off the original Layer 2 frame, performs a route lookup, and adds a new Layer 2 frame, routers can also connect different types of Layer 2 networks. Here, you see Network 2's data link is now using Fiber Distributed Data Interface, or FDDI, which is a standard for data transmission on fiber optic lines that can extend in range up to 200 kilometers or 124 miles. When the router receives data from Network 1, it strips off the Ethernet frame, performs a route lookup, and determines the next hop address. After determining that the data will be sent to Network 2, the router adds a new Layer 2 header and trailer using the FDDI frame format. Like the Ethernet frame, the FDDI frame includes source and destination MAC addresses. However, notice that the FDDI frame format shown on screen is very different from the Ethernet frame format. Here's a chance to test your knowledge. As you saw in this section, different devices need access to different layers of data in the 5-layer model in order to send data to its destination. In the simplified network diagram on screen, let's assume PC 1.8 is sending data to PC 3.6. To get there, the data passes through various devices. For each device shown on screen, click a layer in the 5. Here's a chance to recall what you've learned about Layer 2 and Layer 3 addressing. In this example, again, PC 1.8 is sending data to PC 3.6. For each device that forwards the data, we'll let you complete the addressing. Assume that address resolution has already taken place. Modify the Layer 2 and Layer 3 addresses as needed to get the data to its destination. If no change is needed, click the Submit button. If a change is needed, type into the empty fields on screen and then click Submit. Begin with the sending device. PC 1.8 is sending the data. What address should be in each field? Several fields are missing in the routing tables shown on screen. Examine the network configuration and complete the missing fields. When you are finished, click Submit.